On the behalf of Government Engineering College Banswara, I Dr. Sunil Gadhwal welcomes you once again in video lecture classes. As in previous class we had discussed about ultimate analysis of fuel, and today in this series we are going to determine the presence of sulfur in given fuel sample. As we know that if sulfur is present in given fuel, the presence of sulfur to the extent of 0.5 to 3% in ore like iron pyrites, gypsum and coal mines. So on the combustion of fuel, the sulfur in the presence of oxygen will oxidize and produce harmful gases, sulfur dioxide and sulfur trioxides, which are responsible for corrosion. So that during the combustion, the sulfur will increase the calorific value of fuel. So how to find out the percentage of sulfur in a given fuel sample? To know the values of sulfur in given fuel sample, we have to take a fixed quantity of coal, and on complete combustion in bomb calorimeter in the presence of oxygen, by which sulfur present in coal is oxidized to corresponding sulfate, and the ash from the bomb calorimeter is extracted with dilute hydrochloric acid. So the corresponding sulfuric acid will form, and the acid extract then treated with barium chloride. So now we will get a white precipitate of barium sulfate. The solution to precipitate as a sulfate of barium. This barium sulfate precipitate is filtered off, washed and dried to constant weight. So this is the reaction. This sulfur is present in given coal sample, and during the combustion, as we know that combustion will take part in the presence of oxygen. So this will convert into corresponding sulfate, and when we react it with HCl, it will make H2SO4, and then on addition of barium chloride, the sulfate from H2SO4 to react and make barium sulfate as a precipitate. Let the weight of barium sulfate precipitate is W2 gram, and the weight of coal sample taken is W1 gram. Then we can find out the percentage of sulfur by putting the values of W1 and W2 in this given formula. Weight from barium sulfate upon weight of coal sample into 32 by 233 into 100. Now the question arises in mind is that from where we got the values of 32 upon 233. As we know that the atomic weight of sulfur is 32, and on oxidation it is giving sulfate, then on reacting with the HCl it is making H2SO4, and on reaction with barium chloride it is making ultimately the BaSO4 as a final product. So here the weight of BaSO4 is, molecular weight is 233. So from 32 gram of sulfur we are converting into 233 weight of BaSO4. That's why it is 32 upon 233 grams, means 233 gram if barium sulfate is forming, that is forming from 32 gram of sulfur. So percentage of sulfur 32 by 233 into 100. So putting these values, we can easily determine or calculate the values of sulfur present in the given fuel sample. Now the fourth component is determination of S. As we have discussed in proximate analysis, that S is the end point of the complete combustion of any solid fuel, specifically coal, wood, charcoal, etc. So here also, because this ultimate analysis is convection based analysis. So in this also we have what we have to do, we have to burn the given call sample, and on complete convection the ultimate the end product we will get the S. So just we have to weight the final product and we get the quantity of S and dividing it by call sample into 100, we can find out the percentage of given S content. Now the fifth element which we have to find out is determination of oxygen. Oxygen is present in combustible material form with the hydrogen in coal, and thus form hydrogen available for combustion is less than the acute one. High oxygen content coal have higher inherent moisture and low calorific values, because this oxygen will also acquire some space. That's why oxygen normally present in coal sample in the form of moisture. So if any fuel is having more moisture, means we have to pay extra money for transportation. It will be more than on combustion. First the calorific value utilized to escape this moisture from the given fuel samples, and that's why we will get low calorific value from the fuel. So determination of oxygen, it is very simple. The oxygen is determined indirectly by detecting all the combined percentage of carbon, hydrogen, nitrogen, sulfur and S from the 100. So percentage of oxygen formula is 100 minus percentage of the sum of carbon percent plus hydrogen percent plus nitrogen percent plus S percent plus sulfur percent. So putting the values in this formula, we will get the oxygen present in fuel sample. Hoping that you would understood the topic very well and will be able to answer the questions by examiner asking in exam. Thank you.